This question is from Riemann sum. So let's try this. Before you see the solution, it's better if you can do it by yourself and then come and match the solutions. So limit n tends to infinity 1 by n4 product of I equals 1 to 2n n square plus I square to the power 1 by n. This notation is usual, which means product of these elements. Right, so how we go about it? So it's a straightforward in the first go, because you know the idea in these kind of problems n 1 by n is dx. So hence this problem can be written as, let's say suppose if this limit is L, and since log is a continuous function from 0 to infinity, from x belongs to 0 to infinity, hence I can put on limit x tends to a ln f of x is same as ln of limit x tends to a f of x. This is because log is continuous in its domain. So using that idea, we'll take log on both sides, and that simply gives this expression, as you can see, because 1 by n goes on its tail, ln n square plus I square minus 4. Now our attempt is to convert this into I by n. So we'll take n square common, and I by 1 plus I square by n square is separated, and therefore the given limit just takes 1 by n sigma n square plus I square minus 4 log. From here we can write this limit in this format, and now sigma 1 I equals 1 to 2n. If we evaluate 2 ln n, since 2 ln n is constant, so that will be out, and just 1 plus 1 plus 1 2n times, so that will give 4n ln n, right? And then cancel, so this expression, the first expression, gives 4 ln n, and that gets kicked with this. So finally we are left with 1 by n sigma I equals 1 to 2n ln 1 plus I square n square. Now you can observe that this looks like Riemann sum for the function ln 1 plus x square, and if you take the partitioning of 0 to 2 by dividing this into interval of 2n, and we can use the right-handed in point of each interval as selection of points, and this is very usual practice. So that I was explaining over here, where you take I by n as x and 1 by n as dx. And since I is operating from 1, so 1 by n when n tends to infinity will go to 0, and I 2n when n tends to infinity will go to 2. So the given Riemann sum gets converted into this integrals. And now it's easy to do it because we can use integration by parts. So let's take 1 as the first function, and this entire expression ln as second one. I'll get x ln this minus 0 to 2 this integrals. And 2x square by 1 plus x square is easy to decode because we can add 1 and subtract 1 over here, and this integral can simply be done in these two separated way. So finally ln L is 2 ln 5 minus 4 plus 2 tan inverse 2, and the final answer to this beautiful problem is 25 e to the power minus 4 plus 2 tan inverse minus 2. So this is a usual way of attacking these kind of questions, and especially when things are in product, you can take log and try to convert into Riemann sum. And the obvious motivation for these questions will be replacing I by n as x and 1 by n. For a strictly b more than a, and both are non-negative, strictly positive, right? And both are strictly positive. So we first integrate this by parts. So we'll take 1 as the first function, so we'll get x times this plus this integral. And now if I'll put the value of b, you can see ab will get cancelled, so we'll have just b by b, which goes to cos inverse 1, and cos inverse 1 is 0. Similarly at a, so this terms directly gets to 0, right? So now we can complete the square, and we can divide it by a plus b. So this quantity inside can be made a perfect square. And now the obvious motivation is to assume u as x minus a by 2, and that will convert this into this integral. So you can just pause the video and check it. If I'll rewrite this, you can rewrite this expression as this. And now let's separate this into two parts. And by separating, again rewriting this expression as is already shown in the solutions. Similarly, we can again write this into two parts, because we can write this ab whole square, why this is a separate part in this. So finally we'll have this three different integration into pictures, right? Now the first integration, as you can already see, is 0 because this is an odd function over here. Since an odd function, so from minus a to a f of x dx will die because of the reason the function will be symmetric about origin. So positive area is going to cancel negative area. Okay, since the integral is odd function over symmetric origin, so our integral becomes just this minus this. And now this can be handled because it's like something alpha square minus u square. So that's sine inverse 1 minus sine inverse minus 1. So that's pi. Right, for the second integral, again we can assume since we have u square times something, so we can assume u as b minus a by 2 times b. This is happening like this motivation is because of the symmetric introduction of these variables. Right, because I can make this as 1, so it's 1 minus u by b minus 1 by 2. So with that motivation, the integral converts into minus 1 to plus 1, this one. And now we can see 1 minus b a square demands us either to assume b as cos theta or sin theta. Otherwise here there is less chance because we have linear. It's like 5b plus 4 kind of thing under root 1 minus b a square du. So an obvious motivation here will be to keep u as cos theta, and that converts this integrals into time. Now again we can assume this as a constant. So basically we have 0 to pi 1 plus c cos theta theta is this. Now that's not very difficult to see. So finally we need to see this integral, how it's evaluated to. So one way is to convert cos theta into tan theta by 2. So 1 minus tan square theta by 2 by 1 plus tan square theta by 2. And this you can do very simply as because it's cos square theta by 2 minus sin square theta by 2. So you divide it by cos square theta by 2 plus sin square theta by 2. And further dividing it by cos square gives the desired result, provided that's not 0. Okay. So if we can see this, then the final integration will be b minus a whole square by pi 4 times a plus b. So let's assume u as tan theta by 2 with that motivation, and the given integral 1 plus c cos theta gets converted into this new integral, and now applying the value gives pi by root over minus c square. Especially in JEE, this can just be a part of the problem because they can give you a 4 marks problem like this. It can possibly come both in mains and advanced. Right, where you have to find the value of 0 to pi 1 plus c cos theta. And remember, c has to be between 0 to 1 because we have got b square minus c square is always lesser than b square plus c square. So I hope you enjoyed this problem, and moreover the idea was how we are using integration by parts, separating integral, and then getting let's try one more question. And usually this question is not rigorously solved in textbook at JEE level. So let's see how we can solve this rigorously. So the question is determine the triangle of maximum area that can be inscribed in a circle of radius 1. So usually if you see the textbook, the way they'll define this problem as out of all possible triangles having a fixed base, let's say A, the isosceles will have maximum area because isosceles will have maximum height, right? So on a circle, if the point is moving, clearly when these two lengths will be equal, we are having maximum height, so along the perpendicular bisectors. So from there we got it has to be isosceles triangle. So next we'll show that among all isosceles triangle, maximum area must be of equilateral. Okay. So that's also a valid argument, but here I can give you more strong way of attacking this problem. Even with calculus, we can show why isosceles should be maximum. So we'll first try to show the triangle must be isosceles, and then we'll show it must be equilateral. So we denote a unit circle at a set of point R2 with x square plus y square equals 1. So this is our unit circle over here, right? Then we inscribe a triangle in the circle. Now we can always rotate a circle so that the base of triangle is horizontal segment, because let's say even if a triangle is over here, still we can make this base slide to here. We can rotate a circle or triangle here because of that symmetricity, right? So I can always assume one of the point as let's say x0 comma y0, and the other point will be minus x naught comma y naught because of symmetricity, where we have made x naught greater than 0. So third vertex can be anywhere, sets xy. So let's show for the maximum area of this, we must have first isosceles case. The area of triangle is half into base into height, half into base into this difference y minus y naught, because the height is y and this distance is y naught. So hence the height of the triangle is going to be y minus y naught. Base will be half into 2x naught times y minus y naught, right? So it is x naught. Here I have not taken mod on y minus y naught because we are checking with this diagram. Actually, we are making y greater than y naught, but you can take mod in different both situations. So since x naught y naught is not changing, we want to make this as large as possible, where y is the quantity that's varying, right? So this will happen if and only if we must have y equal to 1, because that's the maximum extreme position it will go. So it follows x equal to 0. That's we see that a triangular maximum area will be the vertices, this one, and exactly it's over here, right? So 0, 1. So triangular maximum area must be isosceles, right? Of course, you can give the same argument over here. It should be 0, minus 1. So in either case, it will be isosceles over here, because we have taken a case when y is more than y naught. Similarly, you can take a case when y is less than y naught. Next, we saw isosceles triangle of maximum area must be equilateral. So now the area of triangle will be x naught to 1 minus y naught, where y naught itself is given by root over minus x naught square, right? Because x naught y naught is on a circle, so they will satisfy it. So now among all the bases possible, among all these base possible, we are trying to show that among all these isosceles triangle, which one is going to give me maximum area. Okay, so larger if plus situation, so we have to find the maximum of this function x times 1 plus root over minus x square, because we have plus minus, so the larger area will be with plus, because one will be the above area, other will be lower one. So clearly the above one will be larger, hence we're taking. So just differentiate. So we are making dy dx, setting it to 0 will give this equation, and we are getting the value of x as either 0 or plus minus root 3 by 2. So x equal to 1 is also critical point. So evaluating a at these points, a0 will give 0, a1 is 1, and this is, so the maximum is out of this, and that's the global maximum. And maximum occurs when x is root 2 by d and y is this. So it follows from this, the distance in any two vertices is root 3, and hence the maximum area of any triangle in a unit circle over here will be the one when it's equilateral triangle. And you can easily find, once you know this result, by basic geometry, because let's say this is 1, this angle is pi by 6, right? So the base of equilateral triangle, we know it's 1 cos pi by 6, which is root 3 by 2, and this is root 3 by 2, and the side length of this equilateral triangle is going to be root 3, hence area is root 3 by 4 into a square, so 3 root 3 by 4, which matches with this description, right? So I hope you got this, and if you want more quality content like this relevant for JEE preparations, please do like and subscribe.